All right, so let's get to the second half of the review. So notice numbers 18 through 29 are really just a bunch of derivatives, but using a variety of the methods that we've talked about this semester. So this first one's probably the easiest one of that group. So if we want to find the derivative, again, make sure that you're writing f prime of x whenever you're ready to find the derivative. You would move the powers out to the front. So this is just a bunch of power rules, basically. Minus 2 plus 0, right? So you get 16x cubed plus 6x minus 2. Okay, so every time we're just moving the power out to the front and reducing the power by 1. Okay, number 19. Remember, anytime it's written in maybe a more unusual form, before you ever begin derivative, we go ahead and rewrite it as something with an exponent, so that when we go to take the derivative, we can do power rule like we like to. So if you move that power out to the front, you're going to get 1/2 times 5, but that's just 5 over 2, and then x to the negative 1/2 power. Okay. Remember, I don't want to see negative exponents, so I would take either this form or 5 over 2 square root of x. Because remember, x to the 1/2 is square root of x, but I would be good with either of those forms, but I don't want to see this one because it's got the negative exponents. So kind of similar on number 20. If we have 7 over 5x squared, we want to rewrite that immediately. So that's going to be 7/5. Notice nothing happens with the 7 over 5. It stays as it is, but then this is x to the negative 2. And now I'm ready to find derivative by moving the power out to the front and subtracting 1 from the power. So negative 2 moved out to the front. If you multiply negative 2 over 1 times 7 over 5, you get negative 14 over 5. And then if you reduce the power by 1, you get negative 3. So I would want to see the answer written just like this. Okay, negative exponents move to the bottom. Okay, 21. 1 over the cube root of x. So let's talk about how I would rewrite that. On the one hand, we have a cube root, so that means it's a fractional power, right? But on the other hand, it's on the bottom, which means it's negative. So it's negative because it's a fraction, and then because it's a cube root, it's to the negative 1/3 power. Okay. Notice, now I'm ready to find derivative, right? I don't write derivative yet, because here I haven't done the move the power to the front thing yet. All I've done is rewrite the problem, so it's going to be negative 1/3 x to the, careful, if you do negative 1/3 minus 1, you're going to get negative 4/3. So in the end, you're going to get negative 1 over 3, and then x to the 4/3 power. Okay, technically speaking, you could write that as negative 1 over 3, and then the cube root of x to the 4th, but I don't think we really need to do that / want to do that. All right, 22. Notice this is the first time that we've had to use maybe product or quotient rule. Notice this is a product, something times something else. So if I wanted to do what I did on the earlier videos, right, this is my first function and this is my second. Anytime you have a first function times a second, product rule is what you need to use. So the derivative would be first times derivative of the second plus second times derivative of the first. Okay, so if you can at least get here, you'll get, partial credit, but if you want full credit on the test, you've got to be able to simplify. So you would distribute this 2x, you would distribute this 4. Okay, so in the end, you get 4x times 2x is 8x squared, minus 2 times 2x is minus 4x, x squared times 4 is plus 4x squared, 6 times 4 is just 24. So in the end, you get 12x squared minus 4x plus 24. So 23 is kind of similar, but admittedly 23 is a little bit uglier just because of that root there. So before I start, I'm going to go ahead and do the rewrite now. Okay, so this second little parentheses could be rewritten as 2x to the 1/2 minus 1. Reason being, if I'm going to do derivative, I need it to look like an exponent. So Let's do product rule again, right? First, because there's a first function and a second. So it's first times the derivative of the first, so we'll be careful. Move the power out to the front. A half times 2 is just 1, so it's going to be 1x to the negative 1/2. Okay, notice the derivative of 1 is 0, so that's all I get there. And then it's plus the second times the derivative of the first. Okay, that one's a little easier. That's 10x. So at this stage, it's really just like the last one. It's just admittedly we have some uglier exponents, right? But just remember your rule. When you multiply terms with exponents, all you do is add the exponents. So I'm going to do 5x squared times this, and I'm going to get 5x to the, so think about that. What is 2 plus negative 1/2? So in other words, 2 minus 1/2 is 1 1/2 or 3/2. 1 times this is just itself. 2x to the 1/2 times 10x is going to be 20, right? And then again, we just add the exponents, but what's 1/2 plus 1? Notice it's 1 1/2 again, or 3/2. And then minus 1 times 10x is just minus 10x. So in the end, you get 25x to the 3/2 minus 10x, and then plus 1 over x to the 1/2. Okay, I know it may not be the most satisfying answer in the world, but that's what we get. Okay, kind of some unusual exponents on that one. All right, so for 24, we have f of x equals 1 over x squared plus 1. Now notice we can't use the product rule anymore, right? We have to use quotient rule because we're dividing now. So the derivative is going to be bottom times derivative of the top. But careful about that. What would be the derivative of 1? Well, it would just be 0. And then minus the top times the derivative of the bottom, which is 2x. And then it's all over the bottom squared. So notice I get a bunch of cancellations here, right? So I just end up getting negative 2x over x squared plus 1 squared. Okay, and that's it. That's all I can do. Can't cancel anything out. I've got to leave the bottom alone for the most part. So 25 is also a quotient rule. So g of t equals t squared plus 1 over t minus 3. So if I want the derivative, I'm going to say that, right? So I do bottom times derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, notice if you kind of say that as you write it, say the formula in your mind, you'll commit it to your memory better. So I'll distribute here. Make sure that this minus also distributes. Okay, notice the 1's not really going to affect anything, right? So I end up getting 2t squared minus 6t, and then minus t squared minus 1 all over the bottom unchanged. And then if I clean it up, I get t squared minus 6t minus 1 over the same denominator. Okay, no cancellations that I can do there. That's just it. Okay, for 26, notice that we have one of our special cases as part of the problem. So remember what I said when we were first learning this. Any piece with an x in it is its own function. So this is its own function, but so is this. So even though there's no like multiplication dot or multiplication sign, this is a product rule problem. So you might find on the test that there may not be always, a clear indication that it's being multiplied, but if you have two things with x in it, that is two separate functions. So product rule, let's just do that. First times derivative of the second. Remember, derivative of ln of x is just 1 over x, plus the second times the derivative of the first. Okay, so for this one, just kind of clean up as you go. X squared times 1 over x is just going to be x. Think of it like x squared over x. So one of those is going to go away. And then typically, remember, we write the natural log thing separate or last. Okay. Although if you would have left it like that, it wouldn't have been wrong. Okay. Just typically we write our e's and our ln of x as last. All right, 27. 3e to the x minus 4x cubed. Notice in this case we also have two functions, right? But we're not multiplying them or dividing them. We're just subtracting them. So we can just use the sum difference rule, which just says, hey, find the derivative of them and keep the sign the same. So the derivative of 3 times something, remember you bring the 3 down. Then the derivative of e is just itself. But then the derivative of this guy, move the power out to the front, is going to be minus 12x squared. Okay. Notice we do power rule on this one. We don't do power rule on something to the x power. Okay, we have formulas for that. Those are our special cases and we treat them as such. All right, 28. So if I want to find the derivative of this is just straight up, do you know the formula or not? This is the general exponential rule. So the derivative of an exponential function is just itself, but then times the natural log of the base. And that's actually all you can do there. There's no simplification. That's it. That's your answer. All right, so lastly for this little group of problems, and then we'll move on to the final word problems of the review. So if we have r of x equals 3 natural log of x plus log base 3 of x squared. Before I start doing derivative, I'm going to rewrite the original. So in other words, I'm going to use my logarithm rule that says this is allowed to move out to the front. So this is 2 log base 3 of x. So the derivative is going to be move the 3 down. The derivative of ln of x is 1 over x. For the second piece, move the 2 down. And then the derivative of this thing, remember what that looks like? It's always 1 over the natural log of the base and then times 1 over x. Notice it's very close to this one, right? It's just got this extra little piece in it. So in the end, you get 3 over x plus 2 over x times ln of 3. Okay, they're not like terms, can't add them, they don't have common denominators, none of that stuff. All right, so for the word problems, just make sure that you read carefully and look for kind of key phrases. So part A says find the slope of the tangent line to the graph of h of x equals 3x minus x squared. So when you see the phrase slope of the tangent line, that should automatically make you think derivative. So the derivative of that is going to be 3 minus 2x. Okay, but then at the point x equals negative 2, notice I gave you that in the problem. So now you're just going to plug it in, right? So m is going to be h prime of negative 2. So it's 3 minus 2 times negative 2, or 7. Okay, so that's all for part A. That's your slope. And then for part B, make sure you know this formula, y minus y1 equals m times parentheses x minus x1. So we'll just plug in what we know, right? We were given the y value if you look back at the point. So it's y minus negative 10 equals 7 times x minus negative 2. And so if you work all of that out with FOIL and stuff, you're going to get 7x plus 14, right? And then you're going to subtract 10 from both sides, so it would be plus 4. Okay. Part C. So it says identify the values for which the tangent line is horizontal. So tangent line should remind you, hey, if they mention tangent line, they're speaking about the derivative. So here was my derivative from part A, right? And I'm going to remember that tangent lines that are horizontal have slopes of 0. So remember, horizontal line slope, always, always 0. And then we just solve from there, move the 3 over and all that good stuff. So we'll get x equals If we subtract 3 from both sides, right, so we have negative 2x equals negative 3, and then divide both sides by negative 2, we'll just get x equals 3/2. Okay, so at x equals 3/2, the tangent line is horizontal. That's what we can say for sure. All right, let's look at 31. So 31 is technically kind of a physics example, but it doesn't really matter because I told you all the information you needed. Okay, in part A, I said find the velocity function, and I told you that the velocity function was the derivative. Okay, so in other words, just don't overthink it, just find derivative. So that's going to be 3x squared minus 18x plus 15. Okay, so that's it for part A. Told you to find the derivative, and we did. B says find the velocity when x is 0 and x is 3. Okay, so we just need to find f prime of 0 and also f prime of 3. So just plug it in. 3 times 0 squared minus 18 times 0 plus 15 just equals 15. And then here we have 3 times 3 squared minus 18 times 3 plus 15. So just use your calculator for that, but you'll get negative 12. So in other words, we have a positive rate of change here. We have a negative rate of change there. Okay. And then lastly, find the times when v is 0. In other words, you're supposed to be finding t or x in this case. Okay, usually the problem would have t in it, but I used x. So in other words, I'm saying set the derivative equal to 0. Because that's what v is, right? V is the derivative equation. So this just involves a little bit of algebra. You just need to factor. So first I would probably notice, hey, these all have a 3 in them, so I'm going to factor a 3 out. It just gives me smaller, more manageable numbers to try to figure out. So what are the factors of 5 that add up to negative 6? Notice minus 5 and minus 1, they would both need to be negative. So we get 2 answers, right? We get x equals 5 seconds and then x equals 1 second. Okay. So I could talk a whole lot about physics if I wanted to, but not really important, right? We could do that problem without really even understanding, frankly, what velocity is even. Okay, so not important to understand that problem at all. Same thing with number 32. You don't really have to know your alcohol to be able to do number 32. You do have to be able to recognize when should I use derivative versus when should I not. Okay, so this is the formula that gives you the absorption rate for 8 fluid ounces of whiskey in your bloodstream. Okay, so notice part A says, what's the percentage, before we start though, let me just say this. Make sure you read the problem. Like, this is the percentage of blood alcohol. And T is the time in hours. Always make sure you read through the problem before you just jump in and say what the variables actually represent. And that'll help us with part A. So part A says, what is the percentage after an hour of drinking the 8 ounces of whiskey versus after 4 hours? So notice, I didn't mention rate of change, a rate, how fast, anything like that. I just said, what's the percentage? Okay, so the percentage after 1 hour, I just need to use the original formula, right? I just need to find A of 1. So 0.23 times 1, and then e to the negative 0.14 times 1 power. Okay, so we're going to get a decimal here that stands for a percentage. So we're going to get 0.09. Sorry, just kidding. 0.15. Okay, so this person's blood alcohol level is about 0.15%. Okay, well past the legal limit, right? All right, so what about after 4 hours? Now, if you're using kind of logic, I would think after 4 hours, by the way, this is after 4 hours when they've stopped drinking, okay? I would think it would have gone down, except for that's not really how alcohol works, okay? Alcohol absorbs at different rates depending on what kind of alcohol it is, but it takes a while to fully absorb into your bloodstream, as we'll find with the answer after 4 hours. So notice after 4 hours we get 0.19. So our blood alcohol level is actually higher 4 hours later. Okay, kind of surprising if you asked me. Okay, that's just because 8 ounces of whiskey is a lot of whiskey to drink. Okay, and whiskey's pretty stout. All right, but notice the word changing in Part B. Part B says how fast. So when you see the term how fast, you need to think to yourself, hey, I need to be finding derivative. Okay, and the derivative is a little challenging on this problem, so let's rewrite the original. So first, hopefully you recognize what I said before, which is anything with a t in it or an x in it is its own piece. So this is one function, and the e is its own function. Okay, so this is a product rule question. Again, you have to be on the lookout for functions that are kind of put together through multiplication, but maybe there's no multiplication dot or symbol. Okay, so we do need to use product rule. So the product rule says first times derivative of the second. So this one's a little tough. We did a finance question like this. Notice it's not just e to the t. If it were just e to the t, it would just be itself, right? But if we have e to the something else, then we have to use the general exponential function rule. So the derivative of this is going to be itself, but then times the natural log of the rest, basically. Okay, so I think that one's a little tough, especially the derivative, but this is first, this is the derivative of the second. So we still have to do plus the second times the derivative of the first. At least that part's a little nice, right? The derivative of 0.23t is just 0.23. So this is the second times the derivative of the first. So if we clean this up, by the way, if you work this part that I'm circling with my finger here out on the calculator, ln and e are opposite operations. They're inverses. They cancel each other out. So you're just left with negative 0.4. So if you'll do this piece times the 0.23, you're just going to get negative 0.092. So you can verify that now if you want. But that is what you get on the calculator. And then here you're just going to get 0.23 and then the e term. Okay, so I'm going to circle this even though this isn't my answer, because this is going to be how I'm going to tell the percentage change after an hour. Versus the percentage change after 4 hours. Remember, percentage change is how quickly the blood alcohol level or the percentage is increasing or decreasing. So if you do a prime of 1, okay, I don't really want to necessarily show all of that, but we'll just let the calculator do it. So negative 0.092 times 1, and then e to the negative 0.4 times 1 power, and then plus 0.23 e to that same power. So looks kind of ugly, admittedly. So you end up getting 0.09. Make sure you can write that as a rate of change. So this means 0.09% per hour. Notice this is an increase because it's positive. So what that tells you is at an hour after you start or stop drinking, your blood alcohol level is still increasing. Okay, so that would not be the time to drive or anything like that, right? Because your blood alcohol is actually, you are still getting, frankly, drunker at that stage. So now let's plug in 4. Okay, and if you do that, you're going to get a negative. It's not a very high negative though, okay? But notice a negative would mean that you are decreasing your blood alcohol, decreasing by 0.03% per hour. Okay, so we'll put a negative there, but make sure that you say a decrease. Okay. By the way, you're still over the legal limit here, but at least it's going down. So, you know, at some point after 4 hours, it would get down low enough where you could drive or whatever you want to do. Okay. All right, so as you read these word problems, don't focus on the content of the word problem, really, because it doesn't really matter if you know anything about alcohol, okay, for 33. It doesn't really, or for 32, it doesn't really matter if you know anything about velocity for 31. You just have to be able to read the problem and figure terminology like rate of change when they want derivative and stuff like that. All right, but the last few examples are all just straight up business examples. All right, so for 33, we have a profit equation that looks like this. Okay, again, make sure you pay attention to what things stand for. This is the profit in thousands. Okay, and X is the advertising spending in thousands. In other words, we're going to spend a certain amount on advertising and we're going to see, does that increase my profit or not? Because frankly, I probably don't want to spend the money on advertising if it's not making a positive difference in my profit, right? All right, so part A says, what is the profit if Cunningham spends $20,000 on advertising? In other words, think about that for a minute. What are they telling you X is? Not 20,000 because of this right here. This is already in thousands, right? So they're actually telling you that X is 20. And they're not asking you for rate of change. They're just asking for the profit at this level. So we're just going to plug in 20. Okay, and see what we get there. So if you plug in 20, you're going to get 36 and then a bunch of sixes repeating. So make sure you know that this means thousands. Okay, so I don't want you to write 36.6 bar thousands. I want you to write that out as money. So remember, the bar means that there's a bunch of sixes. So it's actually $36,666.67. The last one bumps up to a 7 because there will be sixes after it that will bump it up, right? Anything 5 or higher rounds up. Okay. So the profit, if you spend $20,000 on advertising, is about $36,666.67. Okay, part B doesn't even make you guess for it. It just tells you, hey, find derivative. Okay, so if we move the power out to the front, we'll get negative 2/3 x plus 7. Okay, so that's all there is for part B. And then last but not least, make sure you read the terminology, right? What is the rate of change? So when you see rate of change, that should automatically make you think, hey, I need to use derivative. Okay, so remember, we're going to write rates of change as a rate, right? So first, let's do P prime of 10. And we're going to compare that to P prime of 30. Okay, remember it's 10 and 30 instead of 10,000 and 30,000 because everything's in thousands. So if we do negative 2/3 times 10 plus 7, we are going to get 0.3 with a bar. But again, that's in thousands. So make sure you know how to do that. Essentially, when you have thousands, you just move the decimal place 3 times. Okay, so it's just going to be $333.33, but it's that per quarter. Okay, so in other words, the profit is increasing by that quantity. Okay, so now let's see what happens if we up our game and we spend $30,000 on advertising. Okay, notice if you do that, you get negative 13. So that's probably not where you want to be if you're the business owner, right? So we are losing negative $13,000. We're losing $13,000 per quarter. So this time the profit is decreased by that quantity. So in other words, you are spending too much on advertising in that scenario. Okay, you would be better off back here when you were spending less and you were actually getting more for your money, right? Here you're actually spending more and losing money, so that's not a good place to be. All right, 34. The cost in dollars of producing X units of a certain baseball bat. Here is our cost equation. So make sure you know the various forms of these equations. Make sure you know how cost, revenue, and profit relate to each other. Make sure you know things like average cost, marginal cost, and kind of what those are and what they mean. All right, so part A says find the actual cost of the 3,000 first unit. Okay, so this means we're going to do C of 3,000 minus C of 3,000. Sorry, C of 3,001 minus C of 3,000. Okay, because you can look back at the video for this particular section, but this would be the cost of all the first 3,001 items, and this is the cost of the first 3,000 items, right? So if you subtract them, then you'll end up with the one that you actually want. Okay, so if you want to, you can work those off to the side, but I'm just going to plug them in. So 0.01 times 3,001 squared plus 2 times 3,001 plus 1,000, and then minus the same exact thing, but with 3,000 plugged in. Okay, so if you work these out, and again, I'm confident you can do this on your calculator, you're going to get $106,062.01 on the first group, and you're going to get just plain old $106,000 on the second group for a difference of $62.01. Okay, so that is the cost of the exact 3,000 first bat in this case. And then part B says to find the marginal function. So marginal means derivative. Okay, so let's find the derivative function. So if we move the power out to the front, we have 0.02, right? X plus 2. And notice it told us to find C prime of 3,000. So we're going to do 0.02 times 3,000 plus 2. And if you do that, you just get $62 even. So notice these are close, right? And these are close because this is an approximation for that. Okay, so 62 and 62.01. This is the actual price. This is the approximate. Okay, but it's pretty close, right? And then last but not least, find the average cost function. So remember that looked like C bar. And then the average cost of the first 3,000 units. Okay, so C bar, remember the formula for that is take the cost function and divide it by X. So as far as the function goes, we can just write it like this if we want. But then if we want to plug in 3,000, it'll look like 0.01 times 3,000 squared plus 2 times 3,000 plus 1,000 over X. Oh, sorry, not X, right? We plug in 3,000. But we already did the top, right? If you go back up here, we already got 106,000 here. So there's no need to do all that again if we already did it over 3,000. Okay, so if you work that out, you're going to get right around 35.33. So that means that the average cost per unit or per bat in this case is $35.33 or around that. All right, so 35. The revenue function for the same bat from number 34 is negative 0.05 x squared plus 350x. So I said to find the marginal revenue. Marginal always means derivative. So if you move the power out to the front, you are going to get negative 0.1x plus 350. Okay, that's part A. Part B says to find the average, or sorry, compute R prime of 3,000, and then briefly interpret your result. So I'm not looking for paragraphs when I ask you for that, just FYI. I'm looking for you to just tell me briefly what's going on there. So notice we get $50. Okay, so remember, marginal means the next item, right? So the revenue earned from the 3,000 first bat or unit is about $50. That's what it means. It's a rate of change, so it's describing what would happen if we made one more or if we sold one more. That's what it's telling us. All right, so last problem. Find the profit function if we use the previous two, right? And then find the profit earned when 3,000 items are sold. So for part A, don't forget that profit is always revenue minus cost. Okay, I don't think that's really something we should have to memorize because it just makes sense, right? The money we get to keep would be the money we bring in minus the cost it took us to get that. But let's go ahead and write that down. So the revenue equation from number 35 was negative 0.05 x squared plus 350x. And then minus the whole cost function from the one before it. Make sure you use parentheses here because that minus sign is actually going to distribute to everything. And if you'll include a parentheses, it'll just kind of automatically do that for you. So in the end, I'm going to let you use a calculator for that and combine like terms, but you'll get negative 0.06 x squared because negative 0.05 minus 0.01 is negative 0.06. 350 minus 2 would be 348x, and then minus 10,000. Okay, so that's part of what I asked for. So just to make sure you remember, make sure that you remember that this minus sign, sorry about that, goes to everything. And then also in part A, I think I asked you to find the profit earned when 3,000 bats are sold. One more zero. So it's negative 0.06 times 3,000 squared plus 348 times 3,000 minus 10,000. So if you plug that in to your calculator, you'll get 494,000. Part B, find the marginal profit function. So one more time, derivative. So it's going to be negative 0.12x plus 348. You just move the powers out to the front, subtract 1 from the power. So P prime of 3,000 would be plug in 3,000, right? And then briefly explain what your results mean. So if you plug in 3,000, you're going to get, this is part C, right? If you plug in 3,000, sorry, I had to find my calculator, you're going to get negative 12. Okay, so basically what this means is that the profit earned from which specific item, the 3,000 first unit, right, is negative $12. In other words, you're losing money. Okay, happens in business all the time. So they're not making a profit, they're actually losing in that case. D asks you for the average profit function, which we really haven't talked about, but the point that I had for putting that on the review is if you can remember just what average means in general, then you actually should be able to figure it out. So the average profit will just be the profit over x, right? The profit function over x. So that's just going to be the negative 0.06 x squared plus 348x minus 10,000 all over x. And then the profit per bat when 3,000 bats are sold. So that's just going to be P bar of 3,000. So negative 0.06 times 3,000 squared plus 348 times 3,000 minus 10,000 divided by 3,000. So let your calculator do all of that. Okay, so what you should end up with is about 164.67 per bat or per unit. And then last but not least, it asks you to take that equation you got in Part D and find the derivative of it. So you can use quotient rule, but my strong suggestion would be for us to maybe think about P of x in a different way. Remember, we used this trick back when we talked about this in class too. If you have a big long numerator over a single denominator, you're allowed to do this thing right here. You're allowed to separate them out and just say, hey, that's the same as this over x, that over x. And notice how much easier that's going to be to take the derivative of, because this is just going to be 348, and then this is going to be 10,000 x to the negative 1. So you can use quotient rule as well, but I'll be honest, it's not as easy. So this is negative 0.06 plus, derivative of that's just 0, right? Move the power out to the front, and you get plus 10,000 x to the negative 2. So you end up getting negative 0.06 plus 10,000 over x squared. And then last, plug it in and talk about what it means. So negative 0.06 plus 10,000 over 3,000 squared. Okay, remember we're talking about money, so you would round this to the nearest penny, but I think it works out to be a negative 0.06. Okay, so the interpretation is that the profit is not profit, but the average profit per bat, because that's what this is, right, is decreasing, and it's decreasing because of that negative rate of change. It's decreasing by 6 cents, right? So you can either write 6 cents like that or like this per bat at this level, or at the level of 3,000 bats sold. Okay. Just a final note about the review. Remember, this is just kind of a launching point for you. So if you're doing the review and there's certain types of problems that are troublesome for you, then that just tells you, hey, I need to go back and find other questions like that and practice them. Okay. Remember, for a math test, you don't study like you do for anything else. You study for a math test by practicing problems. So you should be practicing the problems on the review and making note of the ones that are confusing for you and trying to go back and find more questions like that.